Hi, welcome. Let's continue our tutorial on main section 2, the area of solid. In this time, we are taking the prisms. The prisms combined together in one envelope. So we are saying prisms are just for solid which has the same cross section throughout its length. Meaning if you take a solid, if you are cutting it into pieces, each of the pieces to resemble what? Each other, or each of the pieces to be identical. In that case, you are having a prism. So typical example is if we take a butter bread and you are slicing it into pieces, you can see that each of the slide have identical what shape. They all have the same identical shape. If you take a straw and you are cutting into pieces, you see that each of the pieces look alike. They are identical. That is saying that their cross section is the same throughout what? Its length. That's an example of what? A prism. Now, prisms have their name from their end, the face of the end. So if the end is a triangle, they become a triangular prism. If the end is a circle, it becomes what? Circular prism, rectangular prism, a square prism in that shape. We also have a specific name for some, as in the circular prism as well, a cylinder. So we are taking them one after the other. And the first one to take is a rectangular prism. A rectangular prism is called a cuboid, which means it is having the end, the face as what? A rectangle. So let me have that being drawn. So we are seeing this as what? A cuboid or a rectangular prism. This is a rectangle, the back is a rectangle, that their vertices are joined together to form what? A rectangle. Already we are saying that in the beginning, we say a solid must have what? Length. It must have what? Breadth. Then it must have some thickness. So the thickness could be the height. So this is a three-dimensional shape. That's why I say in the beginning that solid are three-dimensional what? Figures or shapes. Okay. Now the attention is on what? Area. How to find the area of this. And we have it in the beginning that we need to find the area by first dismantling the shape into its net. If we dismantle it into the net, then finding the area of each of the nets together give us the total surface area. We can see that when we cut this here, down, you open it out, you'll be forming this. If you open this side also, you'll be forming this. Then you are going to have this very end facing you to be here. The one sitting down there, which is also a rectangle, will form there. The one you are seeing behind, which is the replica of this, will be this. Then the open top will give us this, more or less like a chalk box. The box that we place chalk, marker box, all those things are example of what? Cuboid. All right. How do we find the surface area? We are going to say that this is a rectangular, meaning the area of a rectangle. You know, if you have a rectangle, the area is what? The length times what? The breadth. So it means if I take this, I'll be finding the length times what? The breadth. But let's look at this. In the beginning, I said the top here is facing this. So it means this very end here, that is facing the down here, have its counterpart here. This one facing the down. If you remove this, you will get this shape. This very one, if you remove it, you get that shape. If you take away the top, you will get this. The one facing you, which is facing here, is what we have what as this. So you can see there's a replica. If you look at this, and these are also what? A replica of what? Themselves. This and this are opposite. So it means that the area of this will be the same as the area of this. Likewise, the area of the top is the same as the bottom. The area of the front is the same as what? Behind. So if I want to find the area, I'm using the word top. The area of the top, which is this. You are going to see breadth, right? You are going to see length and breadth. And the length has the same label. So I'll be having the length times what? The breadth. Which, if I want to find the bottom, look at it. The bottom is here. This is also going to be breadth, just as this. This is going to be length, just as this. So the area of the bottom is going to be the length times d. You can see the replica of that. Then let's look at the side facing you. So the area of the front side. The front is what is facing you. We know it is length times breadth as a rectangle. But on this diagram, the breadth is labeled what? Height. Therefore, it will be length times what? Height. Imagine we put here 5. The 5 is going to be the height of this 3D. The same time is going to be the length of this rectangle being removed, which is having a replica behind this and this. So the area of the back will also be the longer side is length. The breadth is the vertical line, which is the same as this. So that will also be the length times what? Height. So you can see that this and this are replica, this and this are replica. Then this will be a replica of that, which is going to be the right and what? Left. So area of the right, which is going to be the longer and the shorter. So this times this, which I can see breadth and what? Height. So that is going to be the breadth times the height, where the area of the left will also be this times this, which will also be the same as the breadth times what? The height. So it means that to find the area, we can't be finding the area just pieces by pieces. We need to find it in totality, meaning adding all together. You can see this and this. Imagine the area of the top is y, and the area of the down is also y. If I am adding the two together, it's going to be y plus y, which is what? 2y. Therefore, the area of the top and the down will just be 2 of the y, which is 2 of L and B. So first I'll be having this, which is going to be 2 of what? The L times what? B. Don't forget this could be 2LB. Removing the multiplication does not spoil the value of this. Then if I am taking that of the top, the front and the back, I am also having what? 2 of this. If this is x, it will be 2x. Meaning I'll be having this two LB plus 2L what? H. Then the next one is going to be, if this is Z plus Z, it will be 2Z. Therefore, it will be 2D times what? The height. So this is what we call the total surface what? Area of a cuboid, which is better still of a rectangular what? Prism. We are having 2LB, 2LH, 2DH. And we know that if all of these were to be variables, we are going to factorize the 2 out as the common term. So that gives us 2 into bracket LB plus LH plus BH. So total surface area of a cuboid can be calculated using this formula. What does the L stand for? You know it's the length. The breadth stands for B. And the H stands for what? The height. One trick we have to know is that each of the letters has been used twice. Let's check. Length, length. There is no way of combining them together. So the length will go with something else, where in this case is B. It will go out with the next one, which is going to be the H. The B must be used twice, and the H must be used twice. So don't go and memorize this by saying that LB should be the first, LH should be the second. No. All you need, just close your eyes, is going to be 2 multiplying, it could be the height and the breadth. So we add it. I know the height and the length will also come. So since I use the H and the H already, what is left is what? The breadth and what? The L. Just combining them, making sure 2 is being used at a time. So H, H, B, B, L, L. Then this is the formula. There is no specific lay down criteria which one comes first and which one comes what? Second.